Alright, so today I'm going to show you how to find the molecular formula of a compound. Now you can't find the molecular formula until you first find the empirical formula, and then it's a real easy step to go from there. So the compound that I have chosen today is 2,4-dichlorophenoxyacetic acid, often called 2,4-D, which is a lawn weed killer. It kills broadleaf weeds, but it doesn't kill the grass or the monocotyledon leaves. So the first thing that we have to do, if you notice that we have percents here, simply assume that you have a 100-gram sample, then 43.47% of 100 grams will be 43.47 grams. Gee, that's easy. We just erase the percent or cross it out here, put a G there. Next step is to convert to moles. When in doubt, convert to moles. So 43.47 grams of carbon, 2.74 grams of hydrogen, 32.08 grams of chlorine, and 21.71 grams of oxygen. And then you simply use the molar mass on the periodic table for each of those elements and convert them to moles. Okay, now that we have our moles of each of our elements, the next step is to divide through by the smallest number. The smallest number here is 0.905. Anything divided by itself is equal to 1. So I'm going to take 3.619 and divide it by 0.905, and we get 3.998. That is close enough to a whole number where we can round. If it's greater than 0.8, the remainder, or less than 0.2, round to the next nearest whole number. If it's not, then you can't round. 2.718 divided by 0.905 is 3.00. And then 1.357 divided by 0.905, 1.499, which is 1.5. Now, that's not close enough where you can round it. So what you do to one term, you have to do to everything. You're going to have to multiply everything by 2. In order to get whole numbers. And so we have 8, 6, 2, and 3. So then writing out the formula, write it in the same order that the elements were given to you. We have C8, H6, Cl2, O3. Now we have the empirical formula. Now, in order to find the molecular formula, we're going to take the mass of the molecular formula, so molecular mass. I sometimes call that my target mass, and it's given to me right here as 221.04 grams per mole. And we divide that by the mass of the empirical formula. And so in this case, we have 221.04 grams per mole. And now I have to add up 8 carbons. So 12.011 times 8 plus 6 hydrogen plus 2 chlorine plus 3 oxygen gives me a mass of 22.04. So it turns out in this case that the empirical formula and the molecular formula are one and the same. Now, that's not always going to happen. So for instance, if we had a compound that has the formula CH2O, that's the empirical formula, and we're looking for something with a mass of 180 grams per mole. We would take 180 divided by the mass of the empirical formula. Now, since these are giving us whole numbers, we don't have to go out 3 decimals. Here we have 12 plus 2 is 14 plus 16 is 30. So divided by 30 grams per mole gives me a factor of 6. So to figure out what my molecular formula is, you multiply each of the subscripts by 6, and you would have C6H12 O6.